Alright, and we're live. Totally was prepared today. Haha. It actually takes a while to prepare for these things, which kind of blows my mind. Today I thought an hour and 10 minutes would be enough, and it was not. But I am here. Welcome. I'm gonna do my normal thing where I talk to myself for a while until I find my stream, and then I can start talking to you. So sorry. I do have a question here about water being pumped into and leaking out of an underground tank. And still trying to find myself. So welcome if you're here. We're starting off with a free response question here. I'm going to go over the 3 free response homework problems that I assigned last time. And then we'll just be moving forward with some practice. And then I'm going to talk about a little resource I have for you and assign 3 more free response questions. I'm actually pretty bummed out because I wanted to give some online practice tests sort of things, but a lot of those online practice tests have recently become monetized, so they're no longer freely accessible like they were, which is a bummer. But working through that. Waiting for my computer to actually find my live stream. Convinced YouTube Live is not the least spaghetti code thing in the world because it has a very hard time on the computer of finding it. Those of you who are subscribed probably get notifications, but I don't get notifications for myself, which is a little sad. I am subscribed to myself, however, so that's kind of cool. So let's make sure I'm not streaming and not recording. I am streaming. Okay. Well, sorry if you have found me and I have not yet found you. Welcome if you just showed up. And finally found me. Alright, let's see what I missed. Is this calculator active? No. Hello, Michael, Keith, Matthew, Chelsea, Rose, Caitlin, Andrew, Sam, Kelly, Aspen, Maddie, Raquel, Josh. And again, no calculator on this one. Basically, if the number's bigger than 2 or 3, it's almost always no calculator on these free response questions. So yeah, I put in attendance for the last live stream. So everybody picked the correct class except Maddie. So I was able to put you in, Maddie, but you had signed up for period 4, which was kind of funny. Uh, if you did not get credit and you did watch that, please remember to fill out the attendance document for that live stream. We're at something like 75% attendance. Yeah, yeah. You definitely signed up for class during your waiver. Hey, Daikun, welcome. We're gonna have the attendance document again today because today is one of those like this is class live streams. Uh, yeah. Welcome to those of you who are in the background. And please try out this math question here, which is one of those multiple unit types of questions. Yeah, honestly, I was trying to find an online AP exam. Basically, I've been searching frantically for the last like 45 minutes while trying to prepare for this. And I couldn't really find anything good. Things are a little shaky right now, certainly with the different format and with the fact that everybody is online, so everybody is trying to monetize. So a lot of things are behind paywalls that once were free because they're getting so much use, so they have to upgrade their servers, so they need to be able to afford it, and they maybe have lost their jobs or blah 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 blah. Um, Things are complicated right now. Uh, so yeah, I'm gonna have to figure out something myself. If you're wondering why we haven't had online free response homeworks like we had those few times, there's a very limited number of problems online that are not secure documents that are free response like the ones that we had. That's why the ones that we had were somewhat similar in some cases. Is because there's just very few that have that format. Oh. All right, Andrew. At least you're staying sharp, I guess. Filters are pretty cool. So, um, as long as you have a computer to do all the math, because doing hand math for filters is horrible. I had a class in college that made me do hand math for filters, and it was like 5 full pages of writing small and still getting it wrong. I could get it done in MATLAB, but not on hit by hand. Uh, all right, the duns are starting to pile in. As per normal, we'll wait till there's like 8 or 9 duns before we move forward. Oh, nice. uh, yeah, filters are so freaking cool. That the whole like picking the optimal filter and trying different kinds of filters is was perhaps my favorite part of electrical engineering in general. All right, up to 8 duns. Means I'll wait a couple more seconds and then start going. Hey, folks, if you're finishing these in 9 minutes, which is how long we've been in the stream, and I've been talking to myself for about 4 of those, that's really, 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 really a good sign because, I mean, the AP test is, 45 minutes. It's essentially equivalent length to about 3 of these free response questions. And if this is 30 minutes of work for you, that means you have an extra 15 minutes to look over your answers, check your work, make sure you're doing things right. And that's pretty exciting. So, um, be happy if you're getting more efficient at these, because you'll have more time to check your work and probably be more accurate. And if you aren't finishing these, that's okay too. Just keep refining your skills and get better, and that's what matters. All right, let's begin. So for A, how many gallons of water leak out? Well, we have this rate that gallons are leaking out, and so to find gallons, we actually have to integrate. So we got to integrate from 0 to 3 of root t plus 1, so t plus 1 to the 1/2 dt. So you just integrate this. It's a pretty nice integral. T plus 1 to the 1.5 over 1.5, evaluated at 0 and 3. Plug in 3 and you get 4 to the 1.5 over 1.5 minus 1 to the 1.5 over 1.5. And 4 to the 1.5 is 8, because it's 4 times the square root of 4. 4 times 2. So you get 8 minus 1 over 1.5, which is 7 over 1.5. Huzzah! Did I just get my chat invaded by Wyatt Waters? Is that who I think it is? Maybe not. All right, how many gallons of water are in the tank at t equals 3 minutes? Don't you just plug 3 into the original function? That would give you the rate at time equals 3 that water is leaking out of the tank. So, no, you can't just plug in 3. How many gallons of water leak out of the tank? No, yeah, I did it right. The integral is the amount of gallons that leak out. So the number of gallons currently in the tank at 3 minutes is 30 minus the amount that leaked out. Gallons. I guess I should have put units on this one too. Gallons. It just gives you the first derivative? Yeah, it does. So yeah, to get the actual number of gallons, I have to integrate the rate. So that was a really important part of that. Oops, I goofed and forgot something in the second one here. Because I figured out how much leaked out, and I figured out my starting amount of gallons, which was 30, but I forgot that water is being pumped in at 8 gallons per minute. So that means it's 30 minus 7 over 1.5 plus 24, because if it adds 8 gallons per minute over 3 minutes, we gain 24 gallons in the tank. So we leak out, what is this, 4 2/3 gallons, but we end up adding 24, so we end up with a lot of gallons here, a lot more than we started with. So then we have to write an expression for A of t, the total number of gallons in the tank. And so for this, we're going to use the same model as our previous question. A of t is always equal to 30, the starting amount, minus the integral from 0 to whatever time t that water leaks out. So we could just say root t plus 1 dt. And then plus 8 times t, which is the rate water is pumped into the tank. And so this would be our piece here, our full shebang. All right. So now it says at what time for t from 0 to 120, so we're expanding the interval like crazy here, is the amount of water in the tank a maximum? Justify your answer. Okay, so for finding a maximum, we'd have to take the derivative of the number of gallons, because to find maximums, we always find where the critical point equals 0. So all I do is the derivative of 30 is 0. We're subtracting this integral, but this is like the second fundamental theorem of calculus, and I realized I can't use t's in here because this is the bound is a t, so I should have called these x's, or just any other variable here. And then I just plug in t if I'm trying to take the derivative of an integral, all I do is plug in the bound. And so this is that root t plus 1 sort of nonsense. And then the derivative of 8t is 8. And now all I want is where this equals 0. And so that's where root t plus 1 equals 8, where t plus 1 equals 64, so where t equals 63. Is the integral from 0 to t of 8 dt the same as 8t? Is the integral from 0 to t of 8 dt? Yes. Yes. Yes, it is. Yes, sir. So we get t equals 63. Now, technically we have to choose whether or not this is a maximum or a minimum. So we have to test this critical point and our endpoints. So at 0, we're at 30. If I plug 120 into this nonsense, I get some sort of, let's see, this is hairy. I'm running out of space. I need to delete some stuff here. Turns out the square root's pretty easy, so it's not going to be too bad to figure out the actual answer to this. So I need to plug into this equation to figure out what the actual values are. And I need to plug in like 120. So I get 30 minus evaluated at 0 and 120 of x plus 1 to the 1.5 over 1.5. And the nice part is if you plug in 120, you get 121 to the 1.5 over 1.5. And 121 to the 1.5 is 11 times 121, because it's the square root of 121 times 121. And so we're subtracting that garbage, and we're adding 8 times 120. And the moral of this story is that 11 over 1.5 here is pretty close to 8, so these kind of kill each other, and we end up at a smaller value here than we would at 63. If we plug in 63, we get 30 plus 64 times 8 over 1.5. Minus for the integral part. And plus 8 times 63, which is much, much bigger than the other terms. Could you explain why you switched t to x in the original question? Yeah, absolutely. So the reason I switched t to x, but by the way, the answer is 63. We could also test if it's a relative maximum here. I'm realizing after plugging in all these things that it's actually a giganto pain in the butt. This is the biggest term with absolute extrema. This is a smaller term, and 30 is a smaller term. Both of these are pretty close to 30, making this guy the biggest. But we could have just done first derivative test checked on either side. If it's the only relative maximum, it means it's smaller at the ends. So a few different ways to go through relative extrema. Now, answering that question that Eggroll asked, since I don't know who Eggroll is, the reason this needs to be x and not t is you can't plug in t for t. It's this frustrating math thing where this is a nonsensical integral. Like, if you're plugging in t and integrating t, you're plugging in t for t. So they just notationally don't do this, and so they'll always change it, even though it's a t in our problem all the way up until this point. If you look at AP stuff, they'll always call it a 4dx, and then they'll integrate to 4x, and then they'll plug in 0 and t. So it's just a notational thing. They don't want the same variable in the bounds and in the problem. So that's really the issue there. Oh, right, it's Ethan. Hello, Elise. We just did a pretty horrible absolute extrema question, which D here was that kind of question. The rest of that problem was some setup, but I thought this was a pretty hard question. So we did a lot of easier questions yesterday, and I think this is a pretty hard free response question. Lots of parts were a lot more nuanced than they at first appeared. So that's why I wanted to do this one. It's easier if you have a CAS. Oh, for sure. If you have a calculator, easy, easy. Will you get it wrong if you use T twice? I don't think so, Andrew, but I'm not sure. They never do it. There. Oh, Nick, my Surface that I got for going to ITP as a quad technology project, some summer thing, just came with a stylus, so it's the Microsoft Surface stylus, so I'm lucky I have a really nice stylus. My wife bought one on Amazon that's pretty decent. But a lot of those ones have worse tips, I've noticed. But yeah, I mean, she spent like $10 on one on Amazon. And it's pretty good. So, all right. To talk about ones off the homework here. So first idea here. So I tried to pick some questions that were some of the trickier types of questions. So this storm one was definitely one that threw people for a little bit of loop. And part of the reason it throws people for a loop is because it's a problem built from rates. So pretty similar to the last question. The only thing they gave us in that question was rates. And in this question, pretty similar idea. Because even f of t is a rate. And, whoops, why am I writing on this? Oh gosh, how do I even... I'm so confused. Anyways, f of t is a rate, so this is a rate of a rate when they give us this derivative. And so that's what makes this problem a little trickier. The district has not said anything about grades yet. I know nothing. Oh, can we see the top? Now you can. Now that I clicked that button. All right. So this question was off the document that I linked for it was like a homework sort of assignment. What was the distance between the road and the edge of the water at the end of the storm? So this storm was 5 hours long. We have the rate of change here. And so all we have to do is know that it's 35 meters when the storm began, so that's our initial condition, and then integrate from 0 to 5 of the rate of change based on the storm here. Ms. Cook said that Inslee said that schools will not be doing pass-fail. Yeah, yes. When politicians make decisions, God bless them. Still waiting for the district to tell us how Issaquah's doing it, because every district seems to be handling it differently. Anyways, when you do this integral, you get that at the end of the storm, there's only 26.495 meters between the water and the road. So some dangerous business there. So this was a calculator allowed question. That's why I didn't show the intermediate steps. Using correct units, interpret the value of f prime of 1.007 in terms of the distance between the road and the edge of the water. So this is what makes this problem a little tricky, because f prime is the rate of the rate. So it means the rate is increasing at a rate of 1.007 meters per second squared. So the acceleration you could even use, but the rate of the rate is increasing. You could also call that acceleration at 1.007 meters per second squared. And yes, we can't do pass-fail, but as per normal politician bullcrap, as I'll take a little break here between A, B, and C, D, a lot of school districts are just saying, oh, we won't do pass-fail, we'll do A and incomplete instead, and that's pass-fail. So that's why I have to wait to see what Issaquah's doing first. Oh, per hour squared? Yeah, thank you, sir. That is per hour squared. I fixed it, kind of. Meters per hour squared. If that was second squared, that would be crazy, because this storm's 5 hours, and that the water would have gone over the road. All right. Moving on to C. At what time during the 5 hours of the storm was the distance between the road and the edge of the water decreasing most rapidly? So what I'm looking for is actually the absolute minimum of the rate. So I'm looking for where this rate, which I underline with red, is the most negative. So I want to find the critical points of this equation. So I use my derivative equation and set it equal to 0. 1 over 2 root t equals sine of t would be what I get when I set that equal to 0. So I just want to find where this happens, which is, we have a couple, I graph these in Desmos, so I'm flipping over to my Desmos here, and that's at 0.662-ish, and I should put more decimals, 0.6619, and 2.8404 are my two spots where these meet. And then you just have to figure out which one of these is decreasing the most rapidly, and so you just plug in, this is absolute extrema again, just like the last question. You're plugging in these points, and then the endpoint, which was 5, into the rate equation to figure out which of the rates is the smallest. And if you do that, you get -2 for your starting rate, negative 1.398, negative 2.270, and negative 0.48027. So the storm was craziest here at 2.8404 because it got less crazy at the end. It started off fairly crazy, got a little less crazy, got more crazy, and then abated. And that's, this value would be the time. So the time would be 2.840 hours. After the start of the storm. After storm start. All right, D says, after the storm, a machine pumped sand back on the beach, so the distance between the road and the edge of the water was growing at a rate of G of P meters per day. So they were just pushing it back, because at the end of the storm, what did we say in A? We said it was 26.494 meters, meters away. We need to write an equation involving the integral expression whose solution would give the number of days that sand must be pumped to restore the original distance between the road and the edge of the water. So all we need to do is say, hey, I start with 495, and I add the integral of that new rate from 0 to, it looks like P is the number of days they want to choose. And I got to call this a different variable. So, Andrew, this is like that previous question where I actually have to rename this variable even though they call it G of P. Because P is my bound of this, so I call this something different. And I just want when this equals 35 again, which was the original. And so all you had to do for D was set up this piece, which used a part of just an integral of the rate they gave you in the question from 0 to p, and then the desired amount at the end. And so D was actually perhaps the easiest part of this entire question, in my opinion. C was not. The absolute extrema questions are actually hard. By the way, C, this absolute extrema question, this is optimization. You're finding an absolute minimum. That is optimization in a word problem. So that's why that seems harder. All right. Then we had the Mighty Cable Company. This question was a little easier, in my opinion, than the other one here. They sell cable that sells for $120 per meter. For a cable of fixed length, the cost of producing a portion of the cable varies with its distance from the beginning of the cable. So that means it potentially gets more expensive the longer it gets or whatever. Mighty reports that the cost to produce a portion of the cable that is X meters from the beginning of the cable is 6 root X dollars per meter. And so the longer it is, the less profitable it is for them because it costs more every meter that goes by, which is really perverse incentive for Mighty here. So all we have to do to figure out the profit is we're going to do the amount they sell it for, which is always 120 per meter times the number of meters, which is 25 in the question. So that's how much money they're making. And then we're going to subtract the integral from 0 to 25 of this cost per meter here. And if we do this, we get that they're still making money off of this thing. They're making $2,500, which is pretty good. It's a pretty good amount of money to be making. All right. Using correct units, explain the meaning of 25 to 30 of 6 root x dx in the context of this problem. That would just be the cost of producing, that's the word they use in the question, cable from length 25 to length 30. Or more eloquently, how much more expensive a 30 meter cable is to make than a 25 meter cable. So 30 meter cable is this much more expensive to make. And that's probably the way I'd go about describing it if I was explaining it to like my old bosses at my engineering jobs. They did not like this jargony talk. They wanted the brass tacks here. All right. Part C says, write an expression involving an integral that represents Mighty's profit on the sale of a cable that is k meters long. This is pretty easy. We just take our part from the original question and replace the 25s with k's, and that's it. So 120 times k minus 0 to k of 6 root x dx. Chillin'. That's profit. And that, I guess that equals profit. P of k. And last piece. Oh, I guess they said write an expression, not an equality, so I don't even need to put this. I can just put that. Sorry I was late, was attending other classes. No problemo, dude. Don't worry about it. I upload all these, so no problem being late or even missing this. I realize I'm only doing it once, so that isn't convenient for everyone. All right. And then the last part says, find the maximum, absolute extreme again, profit that Mighty could earn on the sale of one cable. and justify your answer. This means do absolute extrema. So our play here is to take the rate. So we take the derivative of this equation here, which is just like 120 for the derivative of 120k minus 6 root k for doing the derivative of the integral, the second fundamental theorem of calculus. And we just set this equal to 0. We move this to the other side. We get 120 equals 6 root k. We divide by 6 on both sides. We get 20 equals root k. So k is 400. And so their actual maximum profit, their actual maximum profit happens at 400 length. So they actually make a lot of money when they produce really long cables, like 400-meter cables, and they start losing money after 400. Now, we do have to prove this, so we could test values on either side. So if we plug 400 into the original, or is there an easier way here? I'm trying to think to prove this. Oh yeah, there's a way easier way. Literally just graph this, and if you graph it, it switches from positive to negative at 400. So this is a calculator allowed question, and if you graph it, you don't have to do all the absolute extrema. You get that it literally switches from positive to negative. It's the only critical point, and so it has to be a maximum because positive to negative is up to down. And so that makes it the only possible choice. And the maximum profit is we have to plug it back in. So we have to say 120 times 400 minus 0 to 25 of 0 to not 25, 400 of 6 root x dx. And you just figure out this integral, and it spits out an answer of $16,000. So that's pretty fat stacks of cash. So they want to sell big, long cables. Could you say how much it would be to add a 5-meter extension to a 25-meter cable? Trying to think. So I think they build cables a fixed length, which means they can't edit the length. So I think it needs to explain that it's the cost difference between a 30-meter cable and a 25-meter cable, instead of adding a 5-meter extension to a 25-meter cable. But I'm not sure if they would give you credit for that. I would argue it's not as right, but I might not be wrong. So, so that's that question. And last but not least, we have this beautiful question. And these are my favorite because these are the no calculator, the big numbers. So we have a twice differentiable function. We have a derivative graph. So you may have noticed the theme with these was rate graphs. It crosses the axis twice, like, no duh. Like, come on, man. We can tell. Anyways, there's a horizontal tangent at x equals 2. Okay, that's useful. And then we given this random g function, because most of the problem's been about f so far. But then when we look at the first question, it says find the equation for the line tangent to the graph of g at x equals 1. So we got to take the derivative of g, and we get e to the f of x times f prime of x. Okay. So if I want to find the values, I know f of 1 is 2. So that's helpful. So I get e to the 2. And I know f prime of 1 is negative 4. So negative 4 goes here. And chillin', negative 4e squared is my slope. So again, this is g prime. And now all you have to do is, 1, 2 is a point. So you just do Or actually, we're going to have to figure out what g goes through. So g of 1 is e to the f of 1. And f of 1 is 2. So my point is actually 1 comma e squared. And so my tangent line equation is y minus y1 equals slope times x minus x1. Chillin'. Can we do a Kecht problem sometime? Sure. I'll do that as I'll put that on the end of this. It's because this is still homework going over stuff. Slash, I did a ton of Kecht problems in the last, like the live streams before this week. That's why I've toned back on them, but I can bring them back if we want. All right, for b, for negative 1.2 to 3.2, find all the values of x at which g has a local maximum. Okay, so for this one, since g is not f, this makes things harder. So e to the f of x times f prime of x here. This thing, where this equals 0, can only happen when f prime of x equals 0. And the reason it can only happen when f prime of x equals 0 is because e to the f of x is always positive. So actually, the sign of g of x, so even g prime of x here, the sign of the derivative of g of x, which is g prime of x, is always has the same sign as f prime of x, because this e to the f of x thing is always positive. So what this buys us is that all I really have to do is figure out where f prime changes from positive to negative, and it's going to be the same for g. So f prime changes from positive to negative here at negative 1, so that is the only place where g has a local maximum and changes from positive to negative. It would change from negative to positive at the other one because f prime is the only thing determining the sign of g. So it's actually just negative 1 where it has a local maximum. So even though g isn't f, they share the same maximum and minimum. So we're chilling. Oops, I did this all for f. Oh yeah, this question is a little tricky from that. y1 is 2. Unfortunately, it's not, Liam, because this problem's all about g, even though that graph is f, and even though they told you stuff about f. So you actually had to plug up here 1 into g to find what y1 was. So it needed to be 1 and e squared there. All right. Then they tell us the second derivative is all this garbage, which we could have figured out. It's just doing product rule. And then factoring out an e to the f of x. But thank goodness we didn't have to. And then it just says, is g double prime of negative 1 positive, negative, or 0? So all we do is plug in all the stuff we know. So first thing, e to the f of x is always positive. So I don't care about this. It's always positive. Again, it's not going to determine the sign at all. So all that's going to determine the sign is the stuff in that bracket, which was f prime of x squared and f double prime of x. So I got to figure out these pieces. Okay, so first idea here. F prime of x is at the point negative 1, 0. So this is 0. Cool, that doesn't really determine my sign. F double prime of x is the slope of f prime. So at this point, at negative 1, my slope is negative. So this is a negative. So what I have basically is 0 plus negative times positive, which is negative. So it has to be negative. All right. Yeah, this question probably threw people for a loop because they answered everything for f, and g makes things quite a bit different. Anyways, the last part says find the rate of change of g prime, the derivative of g, over the interval 1 to 3. Okay, so 1 to 3 is from here to here. We're trying to find the average rate of change of g prime. So for this, what we're going to have to do is rewrite our g prime equation, which is this. I need this guy. And all I'm going to do is plug in 3 and 1 and divide by 3 minus 1. So I know my denominator already. So it's going to be e to the f of 3 times f prime of 3 minus e to the f of 1 times f prime of 1 over 3 minus 1. This is average rate of change. Plug in 3, plug in 1, divide by 3 minus 1. All right, and we just figure out these by reading the graph here. So f prime of 3 is 0, which is really freaking fantastic because I don't know what f of 3 is. So I already know that the first term is 0. F of 1 is 2, so this is e to the 2, times f prime of 1 is negative 4. That's basically that first question. And then I just divide by 2. So the answer is just 2e squared for 4 divided by 2. And that's it for that one. So this question was sneaky and tested a lot of your kind of first few units knowledge, but in a very convoluted way that was from the later units. So a little tricky there. All right. I don't see any more questions besides can we do more related rates? Maybe. We'll see how time does today. Okay, so now I have these questions for you. You've been watching a decent deal of me. Now try some questions. By the way, we're 4 free response in. Wow. I'm going to go over that PowerPoint in just a moment, actually. Because that's part of what I'd like you doing as homework. And I'll show you in a second. But I'd like you trying out these limits. Let's see how your limit skills have developed. So these should be relatively quick if you're pretty sharp and good at limits right now, if your skills are honed. Oh crud, it's my best friend's birthday today. I have not called him or texted him. Oh well. He's probably working right now. Yeah, like 2 of my best friends have birthdays this week. The 23rd and the 30th. Is the X in number 3 supposed to be an H? Yes. Haha. Look, I can edit it. I didn't know I could do that until just now with the red. Oh, it's your dad's birthday. Oh. I don't think my friend is your dad, though. Sorry. There are a lot of birthdays right now. I think there are a lot of birthdays all the time, depending on if you have a lot of friends. these 4th of July babies? Yikes, let's not get into that. Alright. Let's check these out. For the first one, if you plug in 0, you just get an answer. I got 2. 10 divided by 5. 5 times 2 in parentheses and 5 on the bottom. So that was that. Second one, got 0. Because the power is bigger on the bottom than on the top and at infinity, that matters. And for the third one, good point out, those of you who pointed out that h should be approaching 0 there. What you should have gotten was taking the derivative of 2x squared, which is 4x, and then plugging in -3. So you got -12. Wow. If you didn't get this, this is f of x plus h minus f of x, but with -3 plugged in. I had trouble with the one because it seemed too easy. Yeah. Fair. All right, and yeah, this is just another variety view of limits. I've been doing a fair amount of these lately, just trying to do like a little chapter 1 review, sneaking these in here. These do show up on free response questions, just not ultra often, but who knows what this year's free response will look like, because it's entirely brand new. Do I want to do this? Oh yeah! Hey, the person who asked for related rates, who do I get to be like, I was actually prepared for you? Raquel, I was actually kind of prepared. I got 2 questions for you here. For number 2, we are talking about the same number. Rate of circumference and area are increasing, can't be the same because they have different units, but they can be the same number. Wait, do we have to sign in for attendance? Yes. It is the same document as last time. Also, I believe I re-uploaded it on my homework calendar, and I can put it in chat when we're done. But I have a related rates here, and then I have another question, like a KEKT question. And crud, I actually had something almost ready for this. I thought about putting these on, one of these on here. Let's see if I can pull it up while you guys are mobbing these. Okay. Where did I have that? So let me know when you are done with these. And I'll pretend I'm prepared and stuff. Haha! I do have a form of the question that I can do. All right, cool. Also, Nick, I hope you have the same problem on the actual AP test, that you have trouble with it because it seems too easy. That would be nice. Well, maybe not that you having trouble with it, but if it's easy for you, that would be good. No worries for being behind. Seems like we're just barely going to go over today, not as long as last time. That's... Oh, crud, I still have other things to do. How do you want us to turn in the homework? Margaret, I just want you doing it. That's why I go over the whole thing. So I'm only allowed to assess you on 45 minutes a week, and I wanted to assess you on attendance at the live stream and like being intellectually engaged this week. Next week I might assess you on some homework and maybe only have one live stream login sort of thing. I'm sorry, not 45 minutes a week, an hour and a half a week, 45 minutes twice is what I'm allowed to assess. Until the district changes their tune or gives me some more information, that's what's up. So, will you provide us with ways to get our grades up? I need more direction from the district on whether or not that matters. Because as people have reported, Seattle and Lake Washington have been doing like the A or incomplete. And if that's the case, then there is 0 point in doing retakes. Like 0 point. And so I need to know more about how things are going to happen before I do any of this. I need to know whether or not grades are real. And I just don't have enough information. And trust me, I get information at the exact same time as you from the district. All right, let's mob this. Okay, so the first one you could have done with product rule and stuff, but that was not the smart play. So hopefully you did this. It's the reason why I brought this question up. Because if you did this, the rewrites, where this is to the 0.5 and this is to the second, and combine them to be the 2.5, then you only had to do one term, one chain rule piece. And you just get this to the 1.5 and then times 4x plus 4. It's not wrong if you do the product rule, it's just a lot more work. Grades have always been a human construct. Well, yeah, literally everything we do is a human construct. Thank you, Captain Obvious. All right. And trust me, I'm not somebody who's very excited about grades in general. They basically only exist as a carrot to make you guys care more about being smarter. I don't really care otherwise, which is why we're not taking tests and crap like some other classes. Anyways, sad face, I did product rule. It's not wrong if you do product rule and you end up with something roughly the same, that looks roughly the same, but it's just a lot more work. All right, number 2 says if the radius of a circular puddle is increasing at 1 inch per minute, and the starting radius is 0 at time equals 0, find the time the circumference is increasing at the same rate the area is increasing. So we have two different things. Area equals pi r squared, and circumference equals 2 pi r. We take the derivative of each of these equations, and we get the a dt equals 2 pi r dr dt, and we get dc dt equals 2 pi dr dt. You just set these fools equal to each other, and you get 2 pi r dr dt equals 2 pi dr dt, because you want where the two rates are the same number. And if you do this, it doesn't even matter if I tell you the rate, because they cancel, and the pi's cancel, and the 2's cancel, and you get r equals 1. So that is the radius, the r. Now, the question asks for the time, so I technically haven't finished it yet. But if it increases at 1 inch per minute, then it's also at t equals 1. So I did need that rate for something. And that's it. This semester has been very confusing. Yeah, the world is very confusing right now. Let me tell you. Hello, Kate and Cody. Hope you guys are not going crazy, stuck with your sister. No, just kidding. Hopefully we don't have 15 years of quarantine. Hopefully just a year or so of this sort of thing. All right, so now I put this thing on my website, and this was Ethan was bringing this up, and let's go take a peek at this real quick. Do I want to keep my ink annotations? No. All right. Pulling this up. Here it is on my website. This is linked on my homework calendar. If you click on Crud Muffins, if you click on the... Come on, man. be cool. There's a couple things. The attendance document, Words PowerPoint, and then another set of AP free response questions. That Words PowerPoint is this. And this is really helpful for a lot of people who maybe are reading free response questions and not knowing which method to choose or which one of our notes to look for or that sort of thing. And basically, it just says, when you see find the zeros, this is the set of math steps you do. When it asks you to find the tangent line, this is the set of math steps you do. And it goes through a whole bunch of different vocabulary pieces. So I like this because it's really like an Englishy side and helps a lot on free response questions for people who maybe struggle connecting the words to the actual technique. And so I really, really recommend going through this for many of you. Because this can be a very helpful resource. That's why I linked it today. And then otherwise, I have this. Let's see if it loads. Cool. Just a couple more free response questions. So just kind of a variety of questions here. Yeah, and that's the kind of stuff I want you to be working on before next class. Any other questions on what we're doing? Money is a social construct. Yeah, true. There's actually pretty good evidence to suggest that as we continue to make more stuff than we need as a world, there's no point in having money. Because if we can just give it to everybody and everybody has a base standard of living, there's no point in having money. How often do you look at the attendance log? I looked at it for the first time before the stream today and put in attendance. So I'm probably going to be making a habit of that, assuming I can get my lazy butt out of bed before noon, to look at it in the morning before these streams. So how often do I look at it? I'm going to try to look at it twice a week is the answer to that. But next week's going to be a little different because I'm actually going to be assessing assignment and log, two things. So yeah. Oh, you just put in attendance things? That's good. You AP Lit nerds ranting in here. Anyways, I should probably go. I think we mobbed a bunch of stuff. Seems good. The first question on the homework is the same as 5 on Tuesday's homework. Wait, really? Did I screw up? Oh, crud! Well, hey, there's only 2 questions on the homework. That's pretty cool. I'm fine with that. Whatever, dude. I also put that, like, look at that PowerPoint to make up for that. And look at the word associations. That's fine. Pretend I didn't do that. I copy-pasted from the wrong spot. Oopsies. Because I was looking at both. Ha ha ha. Alright, bye.